Okay, so lesson 7.6 is really just an extension of lesson 7.5. We're going to still be graphing quadratic functions, but the function isn't going to be given to us in vertex form. It's going to be given to us basically in general form, which we've seen before, ax squared plus bx plus c. And then in order to get it into vertex form, we're going to need to use complete the square, which we learned in lesson 7.1. Okay, so we're given a quadratic function to graph, and just like in lesson 7.5, there's specific features that we need to get. We're going to have to graph the vertex, the x and y intercepts, the axis of symmetry, and then any other convenient points to help us kind of fill in the blank. But let's start with getting this parabola into vertex form so that it's easy for us to identify all of those features. Now, when we completed the square before, our function was always equal to 0. So when we moved the constant over, the constant was the only thing on that side of the equation. In this case, we're going to have that y sitting there as well, but it really doesn't affect any of the work that we do. We still want to, step number 1 for completing the square is move the constant to the other side. So I'm going to have y minus 1 equals x squared plus 4x. And just like before, I'm going to leave some room because I know I'm completing the square, which means I'm adding to both sides of the equation. I can also see here that my leading coefficient is already 1, so I don't need to do any sort of factoring. So what I'm going to be adding to both sides is that, I'll do it over here, that b over 2a squared. So in this case, our b we can see is 4, so it's going to be 4 over 2 squared, which is just 2 squared, or 4. So to balance the equation, whatever we do to one side, we have to do to the other. So on the left-hand side, you see we have y plus 3 equals, and now the whole point of completing the square is that right-hand side is a perfect square now. So think about factoring that, and it would be x plus 2 times x plus 2. Now the only step to get y by itself here is to just subtract 3 from both sides. Now we're in vertex form. Y equals basically a coefficient of 1, 2x squared minus 3. And we can go ahead and identify all those features we need from that vertex form. So, starting with the vertex. The vertex is always our h, comma, k. So we have the point -2, -3. The axis of symmetry then is always the vertical line through the x coordinate, so that's x equals -2. I'm going to kind of find everything and then I'll put it on the graph all at once. X-intercepts, those take a little bit of work. We're going to be setting the equation equal to 0. So 0 equals x plus 2 squared minus 3. Just like in lesson 7.5, please don't bother trying to distribute all of that out. This is way easier just to use the square root property, which will bring 3 to the left-hand side. And then we'll take the square root of both sides. So we'll get plus or minus root 3 equals x plus 2. I'm going to go ahead and move that 2 to the other side. So put that in your calculator and get yourself a decimal approximation because you're going to need it to help you actually plot these points. So I'm going to get about -7.3 and -0.27. So those are my x-intercepts. Lastly, I'll find my y-intercepts and then any other convenient points. Y-intercepts, we set x equal to 0, so we're going to get y equals 0 plus 2 squared minus 3, which is just 4 minus 3, or 1. So we have the point 0, 1 on our graph. So vertex, axis of symmetry, x-intercept, y-intercept. Let's go ahead and put out those on the graph, and then we'll see what other points we might want to try in order to sort of fill in the blanks here. So I'm going to zoom in on the graph while I do this. So we have our vertex at -2, -3 here. Axis of symmetry is that imaginary line, so we're going to make it dotted, in which the parabola is symmetric around. Let's see, what else do we have? Let's go ahead and plot our x-intercepts. Those are going to be kind of approximations. We had negative 3.7, so almost 4, about here-ish. And then negative 0.268, so just barely negative on this side of the y-axis. Okay, so now I can start to see the basic shape of this parabola here, but in order to get a better idea of, exactly how fat or skinny to make it, it would be nice to get one more point around here and here. So what I'm going to do is go ahead and test the point x is negative 5 to see what's happening around here, and then x is 1 to see what's happening around here. I'll actually just do that off to the side here. So if I plug in 1 to my equation for x, I would get 6. And if I plug negative 5 in, I would also get 6. Let's go ahead and plot those points. So there's the 1, 6, and then negative 1, 2, 3, 4, 5, 6. So there you go. Now you have a nice, easy way to connect all of your points. So I'll go ahead and do that. Make sure it's curvy at the bottom. It's not a V. And there you have your parabola. Okay, let's do another one where we're going to have to complete the square. This time I'm going to make sure that the leading coefficient is not 1, so you can practice doing that factoring out step. So first you might want to just kind of rearrange this in general form. It makes it easier to look at. So we got x squared minus 6x plus 6. So step number 1 for completing the square is to move the constant to the other side. So we're going to get y minus 6 equals negative x squared minus 6x. But now that leading coefficient isn't 1, so we're going to need to factor that out. So we have y minus 6 equals negative 1 times x squared plus 6x. Okay, again here I'm leaving space because I'm going to be completing the square. So what I put here is that b over 2a squared, where I'm looking at this b and this a. So it's just going to be 6 over 2 squared, or 3 squared, which is 9. Now don't forget though, now that you've factored this out, you're not really adding 9 to the right hand side. You're actually adding negative 9 because it's the product of those two. So to the left hand side it needs to be a negative 9. So let's go ahead and do some simplifying. So here on this side we have y minus 15 equals negative 1 times. The whole point of completing the square is that part in parentheses now is a perfect square. So that's x plus 3 squared. The last thing we need to do to get this in vertex form is to add that 15 to both sides. So we're going to get negative 1 times x plus 3 squared plus 15. Now we have vertex form and we can find all of those features of the graph that we want to find. Starting with the vertex, that one's easy to see. It's our h and our k. So our h is going to be negative 3, our k is 15. Axis of symmetry after that is also easy. It's the vertical line through the x coordinate, so that's a negative 3. X-intercept is always the one that takes a little bit more work. We want to set this equation equal to 0 and solve for x. This is always easily solved by the square root property. I can subtract 15 from both sides, divide by a negative 1, and then take the square root of both sides. So I'm going to get square root, so I'll get plus or minus root 15, which equals x plus 3, but I'm going to go ahead and move that 3 over. Like I've said before, go ahead and get decimal approximations in your calculator so that you know where to plot those points. So our two x-intercepts are about 0.87 and negative 6.9. Finally, our y-intercept we get by setting our x equals to 0. So we have negative 1 times 0 plus 3 squared plus 15. So in this case, we're going to get 6. So we have the point 0, comma 6. So let's put all of that on the graph and then we'll decide what other convenient points we want to choose. This one's going to actually go off the graph a little bit, so I'm going to estimate because my vertex is negative 315. So it's a little bit above this. This one only goes to 10. But that's okay. Just a sketch. Let's see what else we got. We got our y-intercept at 6. So that's on the y-axis here at 6. We have our x-intercepts at 0.87, so almost 1. And we have our other x-intercept at negative 6.8, so almost negative 7. About here. Okay, I did forget to draw my axis of symmetry. That goes through the vertex point. Okay, now it's just up to us to choose a couple of points. You know, I can see the basic shape here. I got a point to pass through here and here. I have nothing to pass through down here. I should probably get one more point around here and here. And then maybe go ahead and kind of complete what's happening in this area too. So for that, we just choose points and plug them in. So we choose x points and then calculate our y points. So I might try, let's see, to get the 2 points down here, it's going to be somewhere around here, I might try x is 2 and negative 8. Those are kind of giving me points just right around here on this side. And then, so if I plug in those to my equation, when I plug in 2, I'll get negative 10. And negative 8, I also get negative 10. So let's put those on the graph. So I have 2 and negative 10. So it's down here. And then negative 8 and negative 10. Down here. So that helps me kind of complete the dots there. And then finally, let's see. That's about good. I might try just getting one more point kind of more in this positive area over here. Figure out kind of what's going on here. So I might try like what's happening at negative 2 right around here and what's happening at negative 4 right around here. So let's try negative 2 I mean and negative 4. And in both cases we're going to get 14. So at negative 2, let me put that on there, we'd be up here near our vertex, and same thing at negative 4. So kind of right where I wanted. Not quite, but it gives us a little bit more of a complete picture. So let's go ahead and draw a parabola, and here's what we got. So you get the vertex, axis of symmetry, and intercepts. And then in terms of choosing points, it's really up to you. You're just trying to get a little bit more of a complete picture. Last one is good. It's going to be a little bit redundant. I mean, it's very similar to the previous example, but I figured if you want to see one more, that's a good thing. So first thing we want to do is complete the square. So we're going to add 5 to both sides of this equation. So we get y plus 5, leave a little space, is 4x squared plus 4x. Now I see that I can factor out the 4 because I need to have a leading coefficient of 1. So I get x squared plus x. Again, I'm leaving some space here and here to complete my square. Now what's added in here is the b over 2a squared. And you're referring to this b and this a. You're looking inside parentheses. So in that case, you're going to get 1 over 2 squared, which is 1/4. Now don't forget, when you've factored it out, you have to take the product of these two things and add it to the left-hand side, which is 1. So now we have y plus 6 equals 4 times, the whole point is what's in parentheses is now a perfect square. So if I factor that, that's going to be x plus 1/2 squared. To get y by itself, we subtract 6 from both sides, and now we have our equation in vertex form. And we can get all those features that we need. Starting with the vertex, that's just h and k, nice and easy. So we're going to get negative 1/2, negative 6. The axis of symmetry is the vertical line that goes through that x coordinate. And then the x-intercept always takes a little bit of work because we're setting the entire equation equal to 0. So we get x plus 1/2 squared minus 6. So first I'll add 6 to both sides. Plus 1/2 squared. Then I'll divide by the 4. So 6/4 is going to be 3/2 on this side. And then we'll take the square root of both sides. So we'll get plus or minus 3/2 on the left equals x plus 1/2. I'm going to go ahead and subtract the 1/2. Get yourself decimal approximations so you know where to put this on the graph. So I'm going to get about 0.7 and about negative 1.7. Finally, get your y-intercept. That's just making your x equal to 0. So you're going to get y equals 4 times 0 plus 1/2 squared minus 6. So in that case, you'll get negative 5. So you have the point 0, negative 5. Alright, let's throw this all on the graph and then pick some extra points that we want. So here we go. Starting with my vertex, which is negative 1/2 and then negative 6. It's right here between those 2 points. And that's also where my axis of symmetry is, right at the 1/2 in between, so negative 1/2. Okay, x-intercepts are 0.73, so a little more than a half. And then negative 1.7, so almost negative 2. So this is a pretty skinny parabola, I can tell already. And my x-intercept is 0, negative 5. So right here. Okay, so I get a pretty good idea of what my parabola is looking like here. Like we said, kind of skinny, facing up. You might want to just figure out one more point of kind of what's happening here. So I might figure out like what's happening at 1 and what's happening at negative 2, kind of just outside these intercepts. So again, you just picked those x's because you were wondering what's happening there. And you just plug them into the equation and get your y. I'll tell you in this case, you'll get 3 for both of those. So we have one more point here. One more point here, kind of helps me complete the dots and see just how skinny it really is. So I'll go ahead and try to do a good job on this iPad here of connecting these and making it curvy at the bottom, not a straight V. And then we have that parabola graphed. Alright, the homework for 7.6 is on Schoology. It's very similar to 7.5, except you're going to have to worry about doing the completing the square in this one.